Okay, this is the centripetal force experiment. So in this experiment, our goal is to measure centripetal force and compare it to another value measured a different way from the spring force. So centripetal, the root word means center seeking. So anytime there's an object rotating, it's going to have some type of centripetal force associated with it. It's whatever force keeps it rotating in that circular motion. So Newton's second law can also be used for rotational motion. So we'll have the centripetal acceleration and the centripetal force. So centripetal acceleration is given by the square of the velocity over the radius. And that's what we're going to use. So we can measure our radius, so we'll have to find velocity. Okay, so our goal, as I said, is to compare our centripetal force to our spring force. So we have this apparatus set up right here. Okay, we have this mass that's going to be rotating. We have a spring, and we're going to attach it here so we can rotate it. So what we have, if I draw a diagram here, we have the spring force pulling inwards as it rotates. So let's go ahead and attach that here. Okay, so as we rotate it, when we do our experiment, this is how we're going to do it. We're going to spin it out here. Now without the spring, I had it centered over this pointer. That's going to be our 0 point, our equilibrium point. So without the spring attached, it was centered right there, and that's something we have to check. So to measure our spring force before we start rotating it, we're going to use these extra weights. Sorry about the angle here. Okay, so we're going to put this hook here, and we're going to add weights until it brings it back out to our equilibrium point. I'm just adding weights here, so we're getting closer. Okay. All right, we're pretty close right there. If we notice, it's almost centered over our equilibrium, and that's at approximately 500 grams, so 0.5 kilograms. So to measure our spring force, we know that our force of gravity is pulling downwards. We have tension and there's spring force. So since our force of gravity is pulling downwards, we can say that's, and it's not accelerating, we can say that's equal to the tension in the string up here. Now we're ignoring that little pulley. We can say this tension is equal to the same tension here, which is equal and opposite to our spring force. So our spring force is just going to be this mass times the acceleration of gravity. Okay, so again, we're going to compare this value of the spring force that we just calculated to a centripetal force that we're going to calculate here, and I'll show you that step next. Okay, so we're going to have a program here. We have a magnet and a magnetic sensor. The only reason for that is to measure its period of rotation. So period of rotation is the time per one rotation. Okay, so that'll be in units of seconds, or you can also call it a second per cycle. Okay, so we're going to rotate this out here. And again, we have to always go to our indicator rod. So we're going to rotate it until it's centered over that rod. And then we're going to hit collect. We're going to get some type of oscillation function. okay? So what I was doing off camera was trying to keep this rotating to try to keep it centered because it will slow down. So you have to keep it rotating with centered over that pointer as much as possible, okay? So we're trying to measure our period of rotation. So we said that's the time per one cycle. So that would be this right here. But we don't know if it was perfectly centered over that indicator rod on that trial. Maybe it was, maybe it wasn't, maybe this one was better, I'm not sure. So let's go ahead and highlight many of them. So that'll give us 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 rotations. We can read off the time that we just highlighted with the mouse. 8.77 seconds is its time, so that was the time for 10 rotations. So we can just take that 8.77 divided by 10. So we have our period of oscillation is 0.877 seconds. Okay, how does that help us? Well, we need to find our velocity to get our acceleration, to get our force. So how do we find velocity? Well, it's easy. We know the time it takes per one rotation. We also know the distance it travels in one rotation. Right, so we know the distance it travels. It travels one circumference of a circle. And we know that the period of oscillation, which we calculated. So distance over time, circumference over period. So this is going to be the velocity as it spins around. So from that velocity, so again, it's 2 pi r over the period. We can measure the radius. We just calculated the period. And from that velocity and the radius, we can calculate our centripetal acceleration and therefore calculate our centripetal force using the mass that's rotating. That's this one here. So let's be careful not to confuse this rotating mass that we use to calculate centripetal force from this hanging mass that we use to calculate the spring force. Okay, we have to distinguish between those two. So on this picture kind of shows you labeled, that's the rotating mass and that's the hooked mass, okay? So we use our rotating mass to calculate centripetal force, and we're going to do that for 7 trials. We're going to do 7 trials, and then we're going to repeat the experiment by changing the rotating mass. So we can do that by adding some extra mass here. Then we'll do 7 more trials. And then we're going to do a third table by changing the radius. So we have to adjust the length here, and then we have to readjust our indicator rod. Okay, so we're basically doing 3 independent experiments. So our 3 independent experiments is the first one, each time we're comparing our centripetal force to our spring force. And we're going to calculate a standard deviation and standard deviation of the mean of our centripetal force. So we will have an average centripetal force plus or minus the SDM based on those 7 trials we did. Okay, and we're going to compare that to our spring force. Right. And that should be about it. Slide it camera went out of focus, so I'll try to redo this. So we're going to calculate our centripetal force, compare it to our spring force, and we're going to do that for 3 separate experiments by changing the rotating mass on the second table, and on the third table changing the radius. All right, thank you.